Welcome back. In the previous videos, we focused on units. Now we will focus on how many digits we should report in a final answer. This is where significant figures become important. In physics and chemistry, we should not report more precision than our measurements actually support. Significant figures help us communicate the precision of measured values honestly. Think about this. If you measure a table with a simple ruler, does it make sense to report the length as 1.238476 meters? Probably not, because the measuring tool may not be that precise. Significant figures are the meaningful digits in a measured or calculated quantity. They tell us something about the precision of the measurement that we make. For example, 6.0 centimeter and 6 centimeter are not exactly the same in terms of precision. The value 6.0 centimeters suggests that the measurement is known to the 10th place. The value 6 centimeters suggests less precision. This is why zeros can be important. A zero after a decimal point can show that the measurement was made to a certain precision. In this 6.0 centimeter, we have two significant figures, and in 6 centimeter measurement here, we have only one significant figure. Now, when it comes to significant figures, there are some rules that we can use to help counting significant figures. The first rule is non-zero digits are significant. So if you have a number like this, 3.72, then here we have three significant figures. The second rule is zeros between non-zero digits are significant. So if you have a number like this, now these zeros are significant. So here you have four significant figures. The third rule is leading zeros are not significant. So if you have a number like this, 0.00450, here these zeros are not significant. So here we have three significant figures. The fourth rule is trailing zeros to the right of a decimal are significant. So if you have a number like this, 2.300, these zeros are significant. So here we have four significant figures. Now the fifth rule is trailing zeros in a whole number without a decimal are ambiguous. So that means it can have several different number of significant figures. So as an example, if you take this number 1500, if you write it in scientific notation, 1.500 times 10 to the power 3 tells you we have four significant figures. If you write it like 1.50 times 10 to the power 3, it tells you we have three significant figures. If you write it as 1.5 times 10 to the power 3, then it can be two significant figures. So it depends on how you write down the number using scientific notation. we can indicate how many significant figures we have. So in this example, if you write 2.3 times 10 to the power minus 4, we have two significant figures. So this number will be 0.00023, and all of these are not significant. This 2, 3 at the end are significant. But if you write it as 2.30 times 10 to the power minus 4, then this will be having three significant figures. Now let us look at the rule for multiplication and division. When multiplying or dividing measured quantities, the final answer should have the same number of significant figures as the measured quantity with the fewest significant figures. This rule is based on the idea that the final answer cannot be more precise than the least precise measurement used in the calculation. For example, suppose one measured value has three significant figures and another has two significant figures. If we multiply or divide them, the final result should be rounded to two significant figures. In this example, we calculate the area of a Blu-ray disc with radius r equals 6.0 centimeters. The area of a circle is given by this equation a equals pi r square. Now, if we substitute our values, pi times 6.0 centimeters square, and if we plug this in our calculator, we get our answer 113.09733355. Now we have so many digits here, and we have to decide how many digits we have to leave. And whenever you do a calculation in intermediate steps, you have to make sure you keep extra digits in the calculation and you round up your answer at the very end. Now here, when we round up this number, we have to consider our calculation. So in our calculation, we have 6.0. So this number have two significant figures. And we also have pi. So in this case, pi can be considered as an exact number because an exact number has infinite number of significant figures. So it is not going to be the limiting factor in a calculation. So any constant value or a number like 2, 4 or any exact number will have infinite number of significant figures. So here in our calculation, uh, so the limiting factor is coming from this number 6.0, and we have two significant figures. So our final answer should have two significant figures. So we can write it as 1.1 times 10 to the power 2 square centimeter. And if you write it as 113, then that's going to be wrong. So the correct answer will be 1.1 times 10 to the power 2 square centimeter, or you can write it as 110 square centimeters. Now, multiplication and division use significant figures, and when it comes to subtraction or addition, uh, we have to consider the decimal places. When adding or subtracting measured quantities, the final answer should have the same number of decimal places as the quantity with the fewest decimal places. This rule is different from the rule for multiplication and division. For addition and subtraction, we focus on place value, not the total number of significant figures. Now, if you look at this example, we have 23.2 plus 5.174. Now, if you add this up, we get 28.374. Now, here 23.2 has only one decimal place. So, in our final answer, we should only have one decimal place. So, the correct answer, if we round this up, will be 28.4. As you can see here, 28.374. So, after this 3, we have 7. So, we can round it up as 28.4. Now, if you look at this example, we have 1.001 plus 0.0003. Now, this gives us 1.0004 and the number of decimal places. So, both numbers have 4 decimal places. So, our final answer should have 4 decimal places. And in the second one, we have 1.002 minus 0.998. Again, both have 3 decimal places, so our final answer should have 3 decimal places. Now here, if you just look at number of significant figures, in this one we only have 1 significant figures as you compare with the significant figures of these. So the thing that we focus on is not significant figures when it comes to addition or subtraction. Now let us summarize. Significant figures help us report answers with appropriate precision. For multiplication and division, use the fewest number of significant figures. For addition and subtraction, use the fewest number of decimal places. In calculations, keep extra digits until the final step and then round your answer at the very end. So in the next video, we will discuss uncertainty and proportional error, which help us describe the reliability of our measurements.